Yes. So here we are where f of k sequence is defined like this one. Okay. Where the positions are f of 0, f of 1, any position you can identify, and at that position, what is the value of the function. Similarly, we are having the name for a sequence which is called as a causal sequence. Causal sequence means only positive values from 0 are defined, whereas the negative answers are all 0. There are no functional values defined for negative values. Negative values means here, for example, f of k sequence is defined as 0, 0, 0, all the 0 term. And at 0 position, the answer is 1, then further 2, 4, 6. So actually your sequence is starting from 1, then 2, 4, 6, etc. And only negative values can answer, all answers are 0 here. So no negative value for the sequence given. Okay. So this is called as a causal sequence. Now coming to the basic operations, like how we can do the operations in the simple algebra, like number system, real number system, complex number system, already you have seen. Same way here also for the sequences we can do the addition. So addition of two sequences is nothing but combined addition for them. So f of k plus g of k. Similarly, if any sequence is multiplied with some non-zero scalar a, suppose, that means the entire sequence values are multiplied with a. That is the second property. Third is the linearity property that all of you must be knowing. That linearity means in the line you can add all these things. So a into f of k plus b into f of k can be separated as a into first sequence plus b into the second sequence. Okay. So these are the simple basic properties of the sequences, which we will be, of course, using while solving the examples in the transformation. Still, I have not defined the transform. We are just on the sequence and their properties, okay, operations. Similarly now, so I think all of you you can just write down this thing that f of k sequence can answer f, like 1 upon 4 is to k as an example, then causal sequence answer and basic operations on the sequence. Okay. Now these are the important results which are very, very helpful in defining the transforms. Okay. So what are those? So this is like a binomial expansion. So series expansions here will help you to find out the sequence, convergence and divergence part. So first series which is written here is 1 upon 1 plus y. Okay, it means 1 plus y raised to the power minus 1. So that is the binomial expansion, which is written as alternately positive negative sign and then powers of y. Please write correctly and carefully. So 1 minus y plus y square minus y cube, all increasing powers of y and alternately positive and the negative side. For what this will go? This will converge for modulus of y less than 1. So can anybody tell me what is the meaning of convergence? When do you call that the sequence or the series is convergent series? So many times you have come across this word. Hmm? Yes, anybody can tell me? I'm just asking a simple meaning of this convergence, nothing mathematically related, any expression. Yes, no idea when the series is said to be convergent.
Gradually reducing.
It is reducing. Okay, reducing to what?
One common answer, is it like that?
Just wait a minute. Sorry. This is the meaning of convergence is nothing but it is tending to a finite number. So somebody told me that it is reducing. Reducing is of course correct. That means it is giving you to a particular value, finite value. So it will converge means that summation holds, and the summation is nothing but the series. Series का मतलब है summation, summing these many terms. So maybe the finite terms or maybe infinite terms. So when finite terms are there, you can easily check whether the summation tends to a finite limit or not. But for the infinite series, like this binomial series, we have written it as the infinite series. It is reducing and reducing and tending to a particular finite number when this particular modulus of y is less than 1 answer, which is there. So y answer modulus means only positive value. Okay, absolute value of the variable, that is y. So this term should be less than 1. Then only this series will converge. Similarly, 1 upon 1 minus y, second formula you can write down. That is, for again same binomial expansion, only plus sign is changed with minus sign. So here you are getting all the positive terms, okay, on the right hand side part. And when convergence region is again same, modulus of y is less than 1. You have to write up to this, okay. So this is a general expansion, binomial expansion, 1 plus y raised to n. And in all these three cases, as you can see, the first term is 1, the second term is y. Okay. So for that, we are writing out this expansion, which is a general expansion in the form of n, and for modulus of y less than 1. Or you may write down this as the combination form. So NCR y raised to r, n are from 0 to n. Similarly, there is one more series which we are frequently using while doing the transformation. That is the fourth one, exponential series. So this is actually the series obtained by the Maclaurin's expansion. If some of you must be remembering that Maclaurin's series, or finding out the approximate value of the function, we are using this Taylor's and Maclaurin's expansion. So there, this e raised to y has this particular form. So fourth formula, which is for the exponential series, is written. Fifth one is the relation, or that is the sequence, put it in the progression form. So A is the first term, second term AR, third term AR square, fourth term AR cube, and etc. It will continue. So whose convergence? This is a simple geometric series. Do you know geometric series or geometric progression? Arithmetic progression, geometric progression, harmonic progression. These are all the sequence के कुछ forms है, where the difference between the first and second term, third and second term, fourth and third term is constant. That is your arithmetic progression. When the difference or the ratio between the second term and the first term, third term and the second term, fourth term and the third term is remaining constant, then it becomes the geometric progression. So here in this case, the geometric progression is going to help us in finding the Z transform. And that is this series. Number 5, formula number 5, you can write down, whose convergence summation answer is A upon 1 minus R. This is a summation answer for infinite sum, and it is convergent for modulus of R less than 1. Okay, so please write correctly. This also series is very, very important, and which we will be using, in which A is the first term, R is the common ratio. Common ratio, as I told you just now, it is a constant answer from the second upon first, third upon second, fourth upon third, and like that terms. And now here the sixth formula, this is defined, that is what is the meaning of modulus of Z. So here we are dealing with Z transform. Certainly we are interested in what is that Z. So Z is of course a complex number, x plus iy, and you will be always getting modulus of Z term, whether it is greater than 1, less than 1, okay, or equal to 1, and like that. So what is the meaning of modulus of Z? Can anybody tell me what is that? Modulus of Z means complex number mein. What is mod z?
Square root of x square plus y square.
Yes, that is true. Mathematically, it is true. But what is the meaning of modulus then? So what is that representing? X square plus y square. What is that representing?
Magnitude.
Yes, it is a magnitude. Magnitude means length. Okay, so it's
And
actually,
it is always positive then, absolute
it
value.
is always positive because it's a length, as I told you. Magnitude means
Yes.
always it, that is why mod. Mod ka matlab hi hai positive. Okay, so you will be getting always the length of a point xy from origin. So it's a distance between the origin and the point xy. If you know, this is x square plus y square under root. Okay, so depending upon that, x square plus y square is equal to 1. What is representing? That is representing geometrically a circle. X square plus y square equal to 1. All of you know this thing. Geometrical presentation of the circle is x square plus y square equal to 1, whose center is 0, 0, radius is 1. So when you say that modulus of z equal to 1, that means it is a unit circle. Means circle having the radius 1. When modulus of z is greater than 1, it implies the points outside the unit circle. And similarly, modulus of z less than 1 represents the points inside the circle mod z equal to 1. That is x square plus y square equal to 1. So just to know the meaning of modulus, okay? That is why this is sixth expression is done. Unit circle all of you can draw. तो सर्कल के अंदर के पॉइंट्स या बाहर के पॉइंट्स, that is the question for the convergence. So in this case we will be dealing with that particular form. Now with all these formulae and the basic terminology for this one complex number and what is the modulus expression, we are now defining this Z transformation. So Z transform, now we know what is the sequence. Okay, sequence, how to define that we know. So f of k is if any sequence, then the Z transform of f of k, that sequence is nothing but, please write this one, summation, sigma notation. I hope all of you know this sigma notation, which is used for summation. This is sigma f of k into z raised to minus k. K is ranging from minus infinity to plus infinity. That will give you, after simplification, the answer is in terms of a z. And therefore, this answer which comes out in the form of a z. Please mute all of you. Somebody's mic is on and I'm getting noise. Okay. So we'll be defining that Z transform of f of k with this particular formula. Summation f of k z raised to minus k, where this z is a complex number x plus I and this z, left hand side z is an operator, which is a Z transform operator. What is the resulting function? The resulting function is in the form of this z. So that is why we are calling this as fz. So Z transform of any sequence f of k is the answer f of z by the definition for this is summation. So this summation formula you have to remember for the transformation. This is the definition of the Z transform. And therefore, for the causal sequence means only positive values. Okay, negative values ka answer 0 hai. There, this is the change. K is ranging from 0 to infinity. Everything is same. F of k is z raised to minus k and answer is in terms of z. Okay, so this is one simplification. It is done. Find Z transform of f of k. So this is finite sequence is given 2, 3, 4, 5, 6 and arrow indicating 0th position. So 3 is your 0th position. Okay, therefore when you find the Z transform of f of k, here f of 0 is 3, f of 1 is 4, f of 2 is 5, f of 3 is 6 and f of minus 1 is 2. These are the positions. So just put it there And the summation over what you are going to calculate, k is equal to -1, that is only 1 point on the left side of 0, and this is up to 6, means that is k is equal to 3. So you will be putting f of -1 z raised to 1. Just put k ka answer. So k is equal to -1, k is equal to 0, k is equal to 1, k is equal to 2, k is equal to 3, and like that. So we will be getting this particular form, which answer is in terms of fz. आ रहा है समझ में? Z transform for the sequence f of k is giving you the value in terms of z. Any doubt regarding this? Yes. Are you with me, all of you?
मॅडम 2z कसं आला नाही कळलं.
Which one?
First
term.
term f of -1 into
f
z
of
to the
minus-
power 1.
F of -1 is 2, no? This
Acha.
is f
2
of
into z.
-1 is 2.
Okay.
And z raised to,
Three.
we are getting substituting k is equal to -1. So z raised to 1 it will come. So that is the first term. Just put z raised to that power and f of whatever the position. So we'll get this particular answer, that is fz. Okay? Yes. So likewise, this is a simple sequence which is calculated and giving you the answer as in terms of fz. Likewise, now I'll just share my pad. So let me take the impulse function, then unit step function, which are very standard functions in your day-to-day calculations. So what they give the answer for the Z transformation. So
Let me someone write down. Are you all? Please once give the presentation.
all of you can see, no, the screen.
Yes, madam.
Yes, madam. Yes, we will go. Today's date I'll put so that this will be remembered with this. Okay, so in general, we are defining any sequence f of k is a sequence defined for negative and positive values of k. Then the Z transform definition, which you are writing it as Z of f of k in the curly bracket, which is equal to summation, sigma notation. Just wait a minute, it is disconnected again.
using some robots because of the address. It's like China, after the military situation, some problem. Is also facing some problems because of the cold, because of the adverse weather. Okay. So what other things? जो पता I don't really aware about that. क्या movie check movie देखा yes. तो जो owner है मतलब वो idea
Yes. So Z transpose f of k, which is written as f of k sequence multiplied by z raised to minus k, and k is from minus infinity to plus infinity. This much you have to remember. Okay, which is giving you the resulting function as f of z, some function of z. That is your expression. So for example, another sequence, if I choose, say f of k is equal to, say suppose, I'll take some finite sequence 4 to 0, minus 2, minus 4, minus 6, something, and the arrow is indicated here, okay, at this position. So what is the meaning of that? Arrow is indicated at minus 2. What is that?
they are using of course they are using.
What is given?
Some applications.
0th position.
From 0 is equal to -2, no?
Yes. So here it is asked to find the Z transpose f of k. Means first of all, you have to just put the positions. Okay. Positions now you can understand. So by definition of the Z transformation, we'll just put it first of all. That is summation of f of k multiplied by z raised to minus k, and k is from, now just see here, what are the values of k defined? This is a 0th position, this is first position. Okay, right side you have to take the positive values, left hand side negative values. So this is 1, this is 2, then left side answer, this is minus 1, this is minus 2, and this is minus 2. These are the positions. Okay, positions for the functional values. So we have to just put the value of k from -3 to 2. आ रहा है समझ में? -3 to 2 summation only we have to carry out. That means Z transpose f of k, which is giving you. Now if I put k is equal to -3, then this is f of -3 z raised to 3 plus f of -2 z raised to 2 plus f of -1 z raised to 1 plus f of 0 z raised to 0, k is 0, and then f of 1 z raised to, what do you write?
-1.
Yes, if we put k is
Minus
equal to 1, then it will be -1, and f of 2 z raised to -2. So this is our series form. That means we are going to calculate f. Now just put the values. F of -3 का answer है 4 multiplied by z cube. Then f of -2 answer is 2 z square. Then f of -1 answer is 0. Okay, so no need to write anything. So plus f of 0 answer is -2. -2 into z raised to 1.
जिथे एक्सटर्नलची साइन घेतो काय करायचं?
साइन मार्कशीटवर साइनच नको.
मार्कशीट नाही, आपला D3 D4
Just mute all of you. I think I can see here few mics are on. Smita. Because I get disturbed. Yes, please mute yourself. If you want to say anything, then unmute and tell me. So this is the next position. So first position -3, then -2, then -1, then 0th position. This is -2 into z raised to 0. Z raised to 0 is of course 1 plus 1 into bracket z raised to, you will write -1 plus last term, that is -6 into z raised to -2. And hence your final answer will be 4z cubed plus 2z square. Now this is -2, z raised to 0 is 1, plus z raised to minus 1 means 1 upon z and minus 6 upon z square. And that is nothing but the function of z. It's a polynomial expression. You got it. Which is function of z. Are you getting? Followed or not?
Yes, madam.
Yes.
Yes, madam.
So we will take now the standard sequences and how they will give you the answer for fz. Let us calculate this one.
Madam, can you just move screen upward once,
Yes, yes,
once,
yes.
please?
You want question?
Yes, yes, madam. Thank you.
मैडम f of
Okay.
-1 इज -4 है.
-4, हाँ ma'am.
हाँ ते 1 लिहिला गेलं. Super.
Hmm.
Last but one.
Yes,
last
yes,
but
yes,
one.
yes,
Yes.
yes. This is -4. Correct. -4. Yes. This will be 4 upon z. Okay, shall we go ahead?
Yes, madam.
Okay, so next you consider this is a standard sequences and their z transforms. So out of which the first one many of you must be using, that is a unit impulse function. Or that's a sequence. Okay. Now how it is defined? It is defined by delta k is equal to 1 and the other answer is 0. This is for k equal to 0 and k not equal to 0. The answer is 0. So there is a impulse of unit length formed. If you draw this as a signal, so this will be the 0th position. K is equal to 0th position. There is a impulse, means length of unit length. So somewhere here, this is your 1, this impulse. And then the rest of the part, like left side of 0 and right side of 0, you will be getting all the 0 values. So this is like this impulse. So immediately jump is there. And again the function, the rest on the right hand side. So that is why it is called as a unit impulse function. Okay, so such function, if it is defined like this, then let us calculate its z transform. Then z transform of this delta k. Let us find out the transform of this. So by definition, it is summation of this delta k multiplied by z raised to minus k, and k is from minus infinity to plus infinity. This is by definition. Okay. Now in this definition, we will be just putting the values for the sequence. So sequence ka only answer is at k is equal to 0, that is 1. The rest all other answers are 0 here. Okay, so actually you are going to get this is equal to 0 plus 0 plus 0. Everywhere it is 0 and the 0th position, which is 1. Delta k answer is 1 and that 0th position. So z raised to 0, which is 1. And further, if you put again the positive values 1, 2, 3, 4, those answers are also 0. Do you agree with this? This is your answer for this one and z raised to minus k. So suppose if you want to put everything in the summation sign, then k. From this minus infinity to plus infinity. Okay, z raised to minus k. So this is the only 0th position. K equal to 0. And therefore, z transform of delta k is equal to, what do you get? What do you get? Answer.
Z to the power minus K.
But K you are putting, no?
Z to the power infinity. 0.
One.
Z to the power
Only
0
one.
means 1.
Yes,
One.
yes. Z to the power 0 is 1. So final answer will be therefore just 1. Correct?
Mhm.
As Z raised to minus K is Z raised to 0, which is 1 here. So only because of that we are getting the answer 1. So delta K value is equal to 1. That means now you can remember this is a standard result for the unit impulse function. That is Z transform of unit impulse function is 1 always. Got it? Similarly, take unit step function, suppose. So unit step function, which is defined as uk, is equal to 0 for k less than 0, and the answer is 1 for k greater than or equal to 0. So the name itself is a step of unit length. That is why it is a unit step function. So here is your sequence. This is your 0th position. At k less than 0, all the values of the function are 0. But for k greater than or equal to 0, so the answer will come out as 1. Any value if you choose for k greater than 0 or equal to 0, then your answer is just 1 here. So maybe for 1, maybe for 2, maybe for 3, and etc. Everywhere you are going to get this one. And that is why this is a step. Yes, a step. This is your step, which is a unit step function. Now for this, let us find out what is the Z transform. Therefore, Z transform of UK. Can you tell me after putting it in the sequence? Summation UK multiplied by Z raised to minus K, K from minus infinity to plus infinity. What is the series presenting? Now, here if you can see that k less than 0 answers are all 0. So it is actually a causal sequence. आ रहा है समझ में? Causal sequence का मतलब है only positive values के लिए defined. Negative values are all 0. So you can write down the summation only for this. K is equal to 0 to infinity. Okay, and the answer for the sequence UK is just 1 multiplied by Z raised to minus K. Means what? If we put K is equal to 0, your first term is 1. If we put K is equal to 1, what is your term? You will be getting Z raised to minus 1.
1
If you,
upon Z.
yes, if you put K is equal to 2, this is Z raised to minus 2. Then Z raised to minus 3 and etc. up to infinity. That means actually it is 1 plus 1 upon Z plus 1 upon Z square plus 1 upon Z cube and etc. the terms. Hello? This is the series you are getting in this case. And this series, if you can identify as a standard series, then it's a summation directly you can calculate. So as I told you, this can be your geometric progression. So if you see this second term upon the first term, the ratio is 1 upon Z. If you see third term upon the second term, what is the ratio?
1 upon Z.
1 upon Z. Similarly, fourth term upon the third term, the ratio remains 1 upon Z. Therefore, this particular series is the geometric series, or this is a geometric progression with common ratio as 1 upon Z, correct? And the first term, we are interested in that, no? Because we know the summation answer. So first term is 1. Here, this is the first term. Therefore, using this already, I have shown you that in the notes, what is the geometric series? Those who have written, can you tell me please? What is the summation for that geometric series? Hmm? S infinity, if you have written no, a plus ar square plus ar cube. What is that? What you have written? This is equal to?
A upon 1 minus R.
Yes, a upon 1 minus r for modulus of r is less than 1. ऐसा लिखा है ना? So in this case, just compare this series with here. So A is in this case 1. R is, what is R? What is R? 1 upon Z. Just put it. Therefore, infinite summation S infinity I will take is equal to 1 upon 1 minus 1 upon Z with modulus of 1 upon Z less than 1. R is less than 1 means mod 1 upon Z is less than 1. And if you simplify this, taking LCM as Z, this will give you the answer as Z upon Z minus 1 for mod of 1 upon Z less than 1, or this implies that mod Z is greater than 1. Am I right? Am I right? Mod Z greater than 1 from this. Just to simplify. And here Z taking LCM, it will go to the numerator. Upon denominator is Z minus 1. So therefore, your answer for the Z transform of this unit step function is Z upon Z minus 1, which is the function of Z for this mod Z greater than 1. So ये जो है, this is called as the region of convergence. Mod Z here, this mod Z greater than 1 is called the region of convergence. Or in short, you can have this as ROC. Okay, so you can remember unit step function का Z transform पूछा तो you can just remember the answer Z upon Z minus 1 for modulus of Z greater than 1. ये important है because if it is a convergent, then only you can get the answer for the transform. सारे sequences they are not giving you the answer because they are not convergent. So only the sequences which will give you the convergent series will be only giving you the answer for the Z transform. So those we are listing here. One we have seen that is a delta K, that is a Dirac unit impulse function. Then this is unit step function whose transform just now we got it. Any doubt regarding this? Anywhere not followed?
Actually, madam, sorry to say, but lot of background noise is there.
You are not getting. From my side it is coming.
Yes, I think, ma'am.
Yes, because we are sitting in the class staff room. No? Okay, I'll correct it. Just wait for 5-10 minutes. I think it is there. Some other class is going on. Because that connectivity issues are there in other rooms, so I cannot go. Just bear today. Next time I'll see how I can arrange it.
Okay, madam, no issue. Thank you, ma'am.
Let me take one more example.
Excuse me, madam, could you please repeat the last sentence of region of convergence?
This one, this is region of convergence means where the function is the range which you are defining. The summation exists for some particular range. What is that range? So modulus of Z greater than 1 and modulus of Z greater than 1 ka meaning we have seen just now. mod z greater than 1 means this is a unit circle. This is x, y, and mod z means x square plus y square. Whose answer greater than 1? So actually you are having this as a unit circle here, and you are getting the convergence outside that. This is a unit length, radius is 1. So outside this circle, you can have the convergence because the series is existing, giving you the finite limit. It's like that. This is a ROC.
Yes.
Just wait a minute. It is disconnected.
नहीं वो open करो पहले. No, it is not visible. Flow check is visible. Yeah. Like become what? हाँ ये ठीक है. This paper नहीं, paper remove करो. सौरभ, वहाँ पे second में the point of this paper नहीं, point of this project. Or innovation.
Yes. So we are here. And depending upon mod z less than 1, suppose it is there, then you will be getting the points inside the circle where your series is giving you the finite limit. That means it is a convergent part. Okay. So let us take one more example where simply you can understand how to take the z transformation. So if f of k, third standard sequence you can have a raised to k. You can call this as third one. F of k is equal to a raised to k for k greater than or equal to 0. A is any non-zero scalar term. Okay, k is of course integer term which is greater than or equal to 0. So the k negative values are not defined. That means it's a causal sequence. Okay, so given sequence is a causal sequence. Given sequence is the causal sequence. So let us take Z transpose f of k, which is summation of a raised to k, z raised to minus k. And k is from, what do you write? K is from
0 to infinity.
0 to infinity. Okay, so this is your sequence. So if you want to write some values, some series form, then you can put the values for k, starting from 0, 1, 2, 3, etc. So if I put k is equal to 0, then I will be getting the first term as 1. Am I right? If I put k is equal to 1, then the second term will be a z raised to minus 1. So again and again it is disconnecting.
मैंने ब्रेक किया अदरवाइज 15 मिनट प्रॉपर हो जाता है.
Yes. So just put k is equal to 1. So I'll be getting a z raised to minus 1. If I put k is equal to 2, it will be a Z raised to
Z
minus means a square z raised to minus 2. Or I can write down this as a z raised to minus 1 ka square. If I put k is equal to 3, I'll be getting a z raised to minus 1 cube and etc. Correct? So can you identify this series? What is this series? Can you identify?
मैंने ध्यान से देखा है कभी कोई प्रॉब्लम नहीं एक जो दो पॉइंट से मैंने बताया ना कहाँ पे प्रॉब्लम है जैसे पेपर हो गया वहाँ पे, या वो डायग्राम में वो मैंने सौरभ को मेल किया था कि वो रिमूव करो.
Like in the previous case, we have identified this as a geometric series. Likewise, can it be a geometric series here? This also.
Okay.
Is it a geometric series?
और कुछ? No.
How to identify geometric series? Always see second term upon the first term, third term upon the second term, fourth term upon the third term, and like that. The ratio remains constant. Is it happening here?
Much more on this soldiers and our country.
A upon Z.
Yes. So this is a geometric series with common ratio R. Common ratio R is equal to a z raised to minus 1. That's the common ratio. Correct term in square, then cube, and then etc. And therefore, summation for the geometric series is this answer, same answer, a upon 1 minus r. So what is first term here? What is the first term?
1.
1.
1.
1.
So it is 1 upon 1 minus r. R means a z raised to minus 1 for modulus of r less than 1. Corrected? And just simplify this thing. This is 1 upon 1 minus a upon z. And for mod a upon z less than 1. And if you take LCM and shift this z in the numerator, it will be z upon z minus a for, what do you write? Modulus of z greater than mod a. Am I right? Modulus of z greater than mod a. And therefore, your z transform of a raised to k sequence is z upon z minus a, which is the answer for fz, capital Fz term, and the region of convergence is modulus of z greater than mod a. Region of convergence is modulus of z greater than mod a. Have you understood? So you can remember this answer for a raised to k. So in general, if I take the example as find z transform of, say, suppose 2 raised to k, I want for k greater than or equal to 0. Then what will be my answer?
2 raised to k for
So I'm just changing a ke badle 2. So what will be the answer for the z transform?
Z
Direct
upon
answer.
Z minus 2.
That's it. Z upon z minus 2, and region of convergence will be modulus of z greater than mod 2.
2.
That is a circle. Okay, so outside the circle of radius 2, you will be having that region of convergence. Okay, so anything A K form may, whatever it is given, you have to just put that answer and remember this is a standard formula. Yes, therefore Z transform of 2 raised to k is equal to Z upon Z minus 2 for mod Z greater than 2. That's it. If it is 1 by 3 raised to k. Similarly, if it is Z transform of 1 upon 3 raised to k, suppose. So you have to put answer as Z upon Z minus 1 by 3 for mod Z greater than 1 by 3 and like that. So just remember answer for f is Z, that is Z upon Z minus A. Okay. And one more I'll show you where k less than 0 ke liye how to get the answer for a raised to k. Similarly, next standard result, fourth one you can write down. F of k is equal to a raised to k only for k less than 0. Negative values of k. So let us work out for Z transform of this. A raised to k, which is summation of a raised to k into z raised to minus k, and k is from what you will write?
Minus 1.
Minus infinity.
Yes, minus 1 to minus infinity. Actually, this is okay. Or you can have minus infinity to minus 1. The powers like that. So a raised to k, z raised to minus k. So in such problems, just put every time substitution or the replacement is for put this k is equal to minus r, say suppose some other alphabet or variable I'm putting. So if k is equal to minus r, then what happens? So when my k is minus infinity, what happens to r? R will be, if k is minus infinity, what will be r?
Plus infinity.
Plus infinity. And if k is equal to minus 1, what is r?
Plus 1.
Plus 1. So your problem is converting into summation of 1 to infinity r value. Okay. And a raised to k ke jagah you are putting minus r. Z raised to r. Am I right? Or this can be written as summation of, I can club this a raised to minus 1 and z in one bracket and whole power raised to r, whose range is 1 to infinity. R is from 1 to infinity. That means if I put r is equal to 1, I'll get the first term. If I put r is equal to 2, I'll get the second term. If I put r is equal to 3, the third term, and like that. So once again, can you identify this as the geometric series with common ratio? With common ratio as a raised to minus 1 into z. And the first term is also same. First term is a raised to minus 1 into z. Okay. And therefore their summation. What is the summation? Summation is first term upon 1 minus r for modulus of r less than 1. That is our geometric series convergence. And therefore, if you simplify, this is z upon a numerator divided by 1 minus z upon a for mod of z upon a less than 1. And that means this is giving you, so if you simplify, a and a is getting cancelled and you will be getting z upon a minus z for modulus of z less than mod a. Am I right? आ रहा है कि नहीं समझ में?
Yes, ma'am.
So just to simplify with LCM, a cancel हो जाएगा and z upon a minus z will remain, which is a function of z. This is, and this is your region of convergence, ROC, mod z less than a. So you can remember, therefore, z transform of a raised to k for k less than 0 is z upon a minus z, for mod z less than mod a. So a ke jagah anything, any sequence if it is given, you can just put it into that form and then simplify. So it can be 1 by 2, it can be 1 by 3, it can be 3 raised to k for k less than 0. So as an example, z transform of 3 raised to k, if it is there for k less than 0, negative values, the answer is z upon 3 minus z for mod z less than mod 3, and like that. Getting? Any doubt regarding this? Yes. So of course, I am just deriving all these summations and giving you the values. But otherwise, in the examination as well as while applying in your field, you can just remember the form. That is, what is the sequence transform? A raised to k ka transform kya hai? That answer you should know. Z upon a minus z, z upon z minus a, when it will come, and like that. So that list of formulae, if you write it on one page, that will be easy for you to solve the examples. How the problem can be derived, that I am telling you. This way, every time putting it in the series form and using the definition of the Z transform. So one more I'll show you here, because this is a basic part which we are doing it. So I'm just deriving. Further, in the inverse calculation, we will be just using direct answer, and with the help of that we are solving the result. Okay, so next, fourth or fifth, whatever that standard form, you can take f of k is equal to a raised to mod k for all k. For all values of k, means positive as well as negative. This is the sequence. So let us work out Z transform for this. Therefore, Z transform a raised to mod k means summation a raised to mod of k, Z raised to minus k from minus infinity to plus infinity. Okay. Now here we will split this summation into two parts. Negative part as well as the positive part. So k minus infinity to minus 1 plus this is k is equal to 2 to infinity. Further, 1 is 0 to infinity. So total answer is minus infinity to infinity, which we are writing it into two parts. आ रहा है समझ में?
Yes, madam.
Yes. So just putting it into these two terms. Now, just for the first simplification, what we will do, we will just replace the terms like how we have done in the previous case. K less than 0 के answer के लिए we have replaced k with r minus of r. ये वाला substitution किया था. Same thing we will do it here for the negative part. Okay. So here for the left hand side part, this is put take color. For the first term, put k is equal to minus r, and therefore when k is equal to minus infinity, your r will be infinity. When k is minus 1, your r will be plus 1. It's only for the first summation. So r is equal to 1 to infinity, a raised to mod k, z raised to minus k. You are putting it. Okay. So z raised to minus k means there also you have to put. Minus k means it will become r. And this is a raised to k, or mod k means only positive value. So it will remain as a raised to r only. Plus this is summation a raised to mod k. Second में कुछ नहीं करना है, as it is 0 to infinity z raised to minus k. Or this means summation of a raised to r, z raised to r, first summation, and second summation r from 1 to infinity, plus second summation a raised to k and z raised to minus k. k from 0 to infinity. This adjustment, did you understand? In the first summation only, we are putting k is equal to minus r. And modulus of k means positive only. So first term is also a raised to k. Second term is also a raised to k. Only that r range is different. And therefore, if we put now r equal to 1, your first term will start from az. Second term will be az square. Third term will be az cube, etc. This is your first bracket. Plus, second way, if you put k is equal to 0, it will start from 1. Plus, k is equal to 1, that is az raised to minus 1. Plus, k is equal to 2, az raised to minus 1 ka square, and etc. Following?
मॅडम
Hmm?
एक्सक्यूज मी हे लास्ट सेकंड टर्म मध्ये काय समेशन ऑफ a to the power r आणि z to the power पण r.
That already we have written, z raised to r. And we are putting
आणि
k is equal to minus r, no? K is equal to minus r we are putting, but under the modulus sign minus r means same r.
we are getting a to the power r.
So a raised to r only. Okay. And again, as you can see, both are the geometric series. Only the ratio will be different. Common ratio is different. So this is infinite geometric series. Second is also infinite geometric series. And this is also geometric series. First is with ratio az. And second is with ratio, common ratio az raised to minus 1. So only that summation you have to put it. So whose summation? First term. Pehle mein first term is az. And in the second series, the first term is 1. So we need only that much. So az upon 1 minus az is the first series answer. And second series answer is 1 upon 1 minus az raised to minus 1. Correct? And in the first term, the region of convergence for modulus of az is less than 1. In the second term, mod of az raised to minus 1 is less than 1. And together, you can put it so together we can write down the answer as az upon 1 minus az for mod of az is less than 1. That means mod z is less than 1 upon mod a. You can write this. Plus second term, if you simplify, a upon z will come, that z will go to the numerator. So this is z upon z minus a for mod of a upon z less than 1, means mod z greater than mod a. Am I right? Mod z greater than mod a. This. Okay. If you don't understand, please ask me. This is just a region of convergence. We are putting it in the inequality form. Inequality is less than 1 upon mod a. And together, therefore, we can write down the answer for this together. Dono mila ke. We can write Z transform of a raised to mod k is equal to fz is equal to az upon 1 minus az plus z upon z minus a for दोनों combine करते हैं z less than mod 1 upon a and mod z greater than mod a. So can be written as mod a less than mod z less than 1 upon mod a. Is this correct? तो इसमें ये भी आ गया, this one, and ये भी आ गया. This one. Correct? The answer is fz equal to az upon 1 minus az plus z upon z minus a. Any difficulty? So if you want to find out the answer for 1 by 3 raised to mod k, so you will be putting directly, this is 1 by 3z upon 1 minus 1 by 3z plus z upon z minus 1 by 3. For the region of convergence is mod 1 by 3 less than mod z less than 3. Am I right? Yes or no?
Yes, ma'am.
Got it? So this is the way we are calculating the results for the Z transform, and few 3-4 we have seen as the standard series, standard sequences. So whose transform answer also you can remember. So ultimately, after solving some few problems, you can easily remember. That is not at all a difficulty. So you can get it. So today, immediately, if you can just write down the sequences, what you have done, and the answers as in terms of FZ. Okay, and 1 or 2, you just solve it for yourself. So that will be easy for you to understand immediately. So that in our next lecture, I'm going to take it on Saturday. So mostly same 2 to 4 or this 3 to 5, same time slot I'll be taking, where again the continuation with the properties of Z transform for the standard sequence and a few examples based on that we can do it. Okay, so for today's part, you can have this as the homework, which you can just do it by at least one derivation, and otherwise you can directly use the direct result formula as such. Okay, so you can have this as the homework problems. Find Z transform of f of k. First one, f of k is equal to 3 raised to k for k less than 0 and 2 raised to k for k greater than or equal to 0. Already we have done both. So you to just, the numbers are defined for a and you should get the answer. If f of k is equal to 1 upon 4 raised to mod k. 1 upon 4 raised to mod k for all k. Find its Z transforms. And one more just to see if you can find out this answer, because that we have not done, but with your knowledge of the series expression. Third one, f of k is equal to e raised to minus ak. E raised to minus ak for k greater than or equal to 0. Causal sequence. Okay, so this third one is only which we have not covered in today's part, but just by applying the definition of the Z transform and the standard series forms I have already given, as I told you that beginning 4-5 jo formulae the that I told you to write down in your notebook. So from that also you can get the answer for this particular problem. So third one you can see e raised to minus of ak. Now, I will suggest for today's part, if you can derive, that will be easy for you to understand. Okay, so instead of directly using the formula, you can just derive it for this number 1/4 raised to mod k, then 3 raised to k, 2 raised to k for the value k greater than 0 and k less than 0. Okay. Will you do?
Yes, ma'am.
Yes, ma'am.
Yes.
Yes, ma'am.
Just wait for a minute. I'll take your attendance. And Saturday, you come with the solution. We will discuss. Okay. And Saturday, I'll see if the noise is again continued. Then I'll search for some classroom here where I can get the connectivity in good form. Then I can shift it over there. Okay. So don't worry.
Hello.
Yes.
Madam, please can you share the today's recording so that we can solve the numericals?
Yes, I'll do.
Okay. Yes, ma'am. Thank you.
Yes, so today we'll conclude this session and we'll meet again on this Saturday. Okay, but please keep on doing the things whenever we are doing some because this is not that much easy like your numerical methods or statistical methods where you can easily get. But some practice is of course needed, and immediately if you do when this is understood, then it will be beneficial for you also as well as to teach for me also. Okay. So till Saturday, see you. Goodbye.
Thank you.
Thank you,
Ma'am,
ma'am.
thank you.
Thank you.